Hello, hello, hello. Good morning, good morning. It is Monday, the 17th of November. Apologies for no advance notice on this, but to be honest, my live solves, I'm intending for this to kind of be while you guys are in school anyway, because I'm going to be less responsive to chat. So I feel a little less guilty about it. Today I'm carrying on with the TMUA Paper 2 series, because that's one where all of the stuff is so completely different than everything you do in class. And the technique can be really tricky to get through, as demonstrated by the fact that in my first run, got 14 out of 20. Second run, 15 out of 20. But today, I'm feeling confident. I'm not necessarily going for full marks here, but I want to see if I can keep that progress going, really attack this with confidence, and really focus on like the exam technique side of things a bit more. So as always, I'll make sure you get the content, like the conceptual stuff. Like we'll sort out if I make any mistakes so that it's a fully correct video. But today I'm really wanting to get after proper exam technique, which means locked in, determined focus right from the offset, not getting a false sense of security, because I know the early questions, if I can do them, there will be later questions which require me to stop, be slower, and really deliberate for a bit. Sorry, train of thought gone. Blah. Rolled out of bed, but it's fine because today is the day. So, let's be honest. I'm just waffling here. I might as well just get into it. But the point is determined focus, not getting stuck on questions, not wasting time, skipping as required, making every question, like, if a question is doable, go get it, get after it. And then the rest of it, do your best. But I think I want to really start taking this seriously in terms of exam technique, because I thought it would be fine and it's currently not fine. So today's the day. Let's demonstrate good practice. Right. So I've got my paper loaded, 75 minutes. I've got my whiteboard loaded. Let's get everything streamed. And by streamed, I mean shared. Hold on a minute. Can you see that? Yes. Okay. So I'm feeling good to go. 75 minutes on the clock. Paper 2, November 2021. Finding the right mindset, because I'm going to come out the gate swinging on this one. That was a mixed metaphor. Anyway. And I'm not going to take individual split times, but I am just going to run through with a timer and trust myself to manage the timing. I don't think I need anything else. But if I do, I'll pause. All right, ready? Let's go. All right, find the value of that. Nice and easy. So integral 1 to 4 of 3x to the half plus 4x to the minus 2. That raises to 3 over 2, divide by that. So 3 over 3 over 2 is that. Raise the power to 3 over 2. 2/3 of that. Yep. Raise to minus 1. And that's between 4 and 1. So that becomes root down to 2, cube up to 8. So 16 minus 4 over 4 is 1. Take off from that, plug in 1, you just get 2 minus, well, it's just 4, which is 15, plus 2, which is 17, which is D. Cool. No split time required. Let's keep it going. Opposite vertices of a square. Zero, 2, 4, 0. Opposite vertices of a square. So the square does something like this. Okay, so actually, whoop, there we go. A, C are the opposite vertices of a square. What is the equation of a line through B and D? Well, that's perpendicular bisector. So we know the midpoint of that is going to be 2, 1 from averaging the things, averaging the coordinates of the points. We know the gradient for A to C is going to be change in Y over change in X. So it goes down 2 for going across 4, so it's minus a half. So the perpendicular gradient is going to be 2 y minus 1 equals 2x minus 2. Y minus 1 is 2x minus 4. Y equals 2x minus 3 is E. Okay. Students chosen at random from a class, each student equally likely to be chosen. Necessary for the probability that the student wears glasses to be equal to 4/15. Okay. 1 is not necessary. For instance, if there were 8 out of the 30 students, it would be fine, in which case 22 would not be wearing glasses. 1 is not necessary. The number of students in the class is divisible by 3. Interesting. So we want 4/15 to wear glasses, and we want 9/15 to not wear, which would be 3/5. Can I come up with an example? 3/5 x. If there are x students in the class, then that is true. So 3x over 5, and that would be a whole number. So x has to be divisible by, well, 15. So if x has to be divisible by 15, then x we can write as 15a. If we write x as 15a, that is 3/5 of 15a, which then becomes 3. So it is 9 times an integer, so it is divisible by 3. That is necessary. 2 is necessary. And 3 is not necessary because it could contain 15 students. So 2 is necessary. 2 is the only one that is necessary, and the answer is C. Let's keep it up. Come on. Okay. Counterexample to the claim. First of all, with a counterexample, we need to make sure that the claim actually applies to the statement or the thing. Does it apply to 1? A is a factor of BC. Then A is a factor of B, which is true, or A is a factor of C. Well, those are both true. That applies, so not a counterexample. Okay, if A is a factor of BC, 16. A is a factor of 16. A is not a factor of B. A is not a factor of C. That is a counterexample. A is a factor of that. But that is a factor of C. That is included in the OR claim. So the only one that's a counterexample is 2, and the answer is C. We'll go in more detail, but I really want to, in the analysis phase, but I really want to smash this run. 5. First error of the following argument. Well, that is true, so that is not an error. I think B is an error because it is entirely possible for cos to be negative. It should have been plus minus, I think. Because the square root itself is just the positive square root. So I think that's it. Okay. I'm happy to lock that in and save some time for where I really need it. 6. Let me give myself some more room as well. Consider the two statements about polynomial f of x. It equals 0 for exactly 3 real values. And the gradient is 0 for exactly 2 real values. Okay, I'm going to use some mapping here. So for P and for Q, let's do the truth statement. For 3, I don't know, not for 3. And then Q is f dash equals 0 for 2. F dash equals 0 for not 2. Let's find out what truth exists here. Is it possible to have this path here? F of x equals 0 for 3. Yes. That is the case of the cubic. Boop-a-doop-a-doop. So there are 2 places where it's the gradient is 0, and there are 3 places where f of x equals 0. So that path does exist. Is this path possible? Is it possible that f of x equals 0 for exactly 3 real values, but the gradient equals 0 for not exactly 2? And I think that is possible. And that is possible in the case of a quintic. So let's say it does something like, it carried on to do something like this, where this point was now above the x-axis. It would still be equal to 0 for 3 real values of x, but this time there would be 4 places where f dash of x is 0. So that path does exist. Okay, does this path exist? Well, surely it does, because even this case, or a quadratic, I can do. In which case, it would not be true. The statement wouldn't. It would be 2 values of 0, which is this start point, and it would not have 2. It would have 1 place where f dash is 0, so it goes to this endpoint. So that path exists. Does this path exist? Can you get 2 turning points or 2 places of yes, and not have right? Well, this we can absolutely do that as well, because that would be the case of the cubic, where it does not. Let me show you. So that would be a cubic did something like this, then it would have exactly 2 turning points, but it would not have f of x equaling 0 for exactly 3 real. It wouldn't have 3 roots. So basically, it is neither necessary nor sufficient for Q. They are completely just, there's nothing meaningful there. So that's D. Okay. So that's the circle of equation. A square has these vertices. A straight line bisects both the area of the circle and the area of the square. What is the x coordinate of the point where this straight line meets the x-axis? Let's draw this out. Okay, center is at 9, 2, radius 2. So it's going to touch the x-axis. Radius 2. I'm drawing this well. Let me move, if I can, this. Because that will already only be at 7. That's 7, 2. And so that's 7, 2. Well, let's call this 1, 0. Let's call this 1, 2. So that can be my square. If it bisects the circle, the only way to do that is to be a diameter. So it has to go through the center. And there's some sort of line. Okay. I think I see how this is going to go. Because if I draw a sort of vaguely straight line, it's going to cut this into a trapezium, which has to have half the area. So y equals mx plus c. Well, we can plug in the fact it goes through this point. So 2 equals 9m plus c. So c equals 9m minus 2. So we know that y equals mx plus 9m minus 2. We know that cuts And we actually know more specifically what that area is going to be. That area, because this is the square has an area of 4, so the area of the trapezium has to be 2. So, and that's x equals 1, that's x equals minus 1. If we plug that in here, if x equals 1, then it would be 10m minus 2. When it's minus 1, it's going to be 8m minus 2. So we know the y-coordinates of those things, so we can find the area of the trapezium. The average of those is going to be 9m minus 2. So 9m minus 2 times, well, 2 of those. So the distance in between times the average of the parallel sides is the area of the trapezium, and the area of trapezium is 2. So 9m minus 2 equals 1, 9m equals 3, m equals a third. So we know the equation of the straight line, y equals a third x plus 1. Oh, of course, it had to have gone through the center of the... Okay, that's how you could have done that faster, by saying it has to go through the center of the square. And that will cross over at x equals minus 3. Damn it. Oh, y equals minus 2. Ah, but I think the point will still stand. By symmetry, I think if I flip that around, I'm just going to say, so it would have been minus 3 on this line, but I think if I'll come back to that. I'll come back to that, but I think I'm going to be fine on that. I'm going to guess 3 for now, but then make a note to come back to that. Damn it, silly execution error. Okay, but I'm not going to waste time on it. Got an hour left. As long as I progress well through this, I'll have time to come back to it, and that's going to be my motivation to really keep my foot on the gas. Okay, there exists statement about polynomial x. There exists a number a and c. So there exists a number c between a and b, such that the differential of c is, so that means there's a turning point between a and b. Okay, so blah, 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 blah. So what they're saying is that's a and that's b, and there's a c in between where the gradient's 0. Which of the following is true? Well, P of A does not have to equal P of B for there to be a turning point in between. So it is not necessary, but is it sufficient? I'm going to say also no, because we can come up with a case. So basically, we've come up with a case now. So let's do this a bit more precisely. So these are not the same y value, but there is a turning point in between, so it is not sufficient. Hold on a minute. Getting my language confused. It is not necessary because it isn't, or it's not sufficient. Knowing that it is not necessary because it is possible to get a turning point without them being equal. And I also don't think it's sufficient because I can come up with a case of, for instance, 1 over x squared, where if I made that a and that b, these would have the same value, but there would not be a turning point in between. So it is also not sufficient. So I think the answer is D. Okay, 9. If that is your polynomial, So it's a cubic. Sufficient to have a real solution. 1 is sufficient. Any cubic will have at least one real solution because it will start. And if you consider the long x behavior, when x tends to minus infinity, f of x tends to minus infinity. When x tends to infinity, f of x tends to positive infinity. The only way that's possible for a continuous cubic is to at some point really go through 0. So it does have a real solution. It is sufficient. So 1 is sufficient. 2, there's a real number t for which the gradient is 0. For a general polynomial. No, because I can come up with a no, not that. Never that. I can come up with, for instance, a quadratic. The derivative is 0 at this point, but it doesn't have any real solutions, so that is not sufficient. There are real numbers u and v, for which multiplying them together gives you something less than 0. The only way to multiply two numbers and get something less than 0 is if they have opposite signs. So one has a positive y, one has a negative y, but you don't have to have a real solution to do that. For instance, 1 over x. If you multiply these together, you would get that this thing is less than 0, and yet it would not have a real solution for it equaling 0. So that is also not sufficient. If you know this, you do not know it has a real solution. So the only one that is sufficient is 1, so it should be yes, no, no, which is D. Okay. First 7 terms of a sequence of positive integers are this. Consider this statement about the sequence. If n is prime, then the term is a multiple of 3 or a multiple of 5. So the claim is only true of n which are prime numbers. 1 is not a prime number. 2, multiple of 3, still works. 3, multiple of 5, still works. 4, not prime. 5, this is not a multiple of 3 or a multiple of 5, so 5 is the smallest number. That is a counterexample, and that is E. If this is true, then there is a real number x and y such that stuff and stuff. Consider the following attempt. Well, that is a true statement. And that is a true follow-on. I don't see why that has to be true. Because you're taking on, so that thing is bigger than or equal to 0. But then if x and y are both positive, for instance, then you're taking off something left. That doesn't have to be true. So 2 does not follow into 3. But what are they trying to say then? Then they're multiplying by x squared, y squared, which is fine because that is guaranteed positive, so it doesn't flip the sign of the inequality. And that does work if a is equal to xy into x plus y, and b is equal to xy. But also, it's not starting at the right point. It should have started here. So it's certainly incorrect. 3 is a candidate. Well, no, that's not wise because it also starts at the wrong point. So you're meant to start there. So I don't think it's any of those. It's proof the converse. It hasn't correctly proved the converse because I don't think 3 follows on logically. That does not, line 2 does not guarantee line 3. Oh, no, 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 I've misunderstood. I've misunderstood. Oh, let me have another look. So that is x squared plus y squared plus 2xy. No, that does follow. Sorry, that does follow. So I think they've proved. So if there exists a real number such that a equals that and b equals that, then I think they proved the converse. Okay, so I'm going to go with C. Hold on, but then what's the difference between that and then B? Divided by. Yeah, I'm not okay. So I think writing in reverse order, I'm not sure 4 going into 3 would work. Divided by x squared y squared. Because what about the case where x squared y squared was equal to 0? Then I think the whole thing would blow up. So I don't think the written in reverse works. I think it is C. Good. Okay. So I just needed to consider that just because I know what they're like. Okay. Polynomial is true if the function is always bigger, then the integral is always bigger. I think that's true. So what they're saying is if there's a function which is always above g of x, then the integral from 0 to anything for f is going to be bigger than the integral from 0 to... Yeah, that's just true. So if g of x, so the integral is definitely bigger because f of x is bigger than g of x. 50 minutes left, doing good. If f of x is bigger, then the derivative is always bigger. No, that is not necessarily true. So for instance, I can have, at this point, the gradient's negative, and I can draw one where here the gradient is positive. So negative gradient, positive gradient, the statement is still true. So 2 does not have to be true. So 3, if the gradient is always bigger, then the function is always bigger. No. So for instance, we can easily come up with a case where, well, in fact, the easiest case of all would be g of x is 1 over x, and f of x is equal to x, because then the gradient is always 1, this gradient is always negative, but the f is not always bigger. Here, g is bigger. So 3 is also not necessarily true, which means the answer is that it is 1 only, which is B. No, that's no. Okay. 13. A region R in the plane is defined by these boundaries. Which of the following statements is true for every point in R? Okay, let me graph this out so I can see what's happening. So this is y is less than x plus 3, and y is less than x squared plus 1. So I'm going to sketch x squared plus 1. I'm going to sketch x plus 3. And this is the region R in between. 3 minus 3, 1. No, lies. It's not the bit in between because it has to be, y has to be less. It certainly has to be less than the line, but it also has to be less than the quadratic. Okay, so it's this region here, this entire region. There. So every point in R, 1 is not true. I think it would have been true if it had been that in-between region, but it's not the in-between region because it's not bigger than the quadratic. Y is less than 5. That's not true of things here. Oh, this feels odd, you know. I'm not sure if this is actually this easy or if it's a trap. Let me think about 2. If you multiply them together, you get something less than 3. Now that I am not certain is true. Because it could be the case that y minus x is minus 70, and y minus x, this thing is also minus 70. When you multiply them together, you would get positive 7. You'd get 4,900, which is not less than 3. I don't think any of them are true, but I'm also deeply suspicious. So if I have time, I'll come back for another look. But I don't want to waste time for the other questions, so I trust what I've done. Don't think I've looked at the signs wrong. So I'm going to go with none of them true, but deeply suspicious. Right. 14. Consider the following simultaneous equations where p is a real number. That and that, which is the range of p. Hello, Anirudh. What's the complete range of p for which the simultaneous equations have a real solution xy? Also, Anirudh, no spoilers if you've seen this already. Okay. Let's see. That's your simultaneous equations. So let's subtract the two equations. That minus that would be p minus 1 lots of 2 to the x. That minus that is 0 equals that minus that is 1. Complete range of p for which these simultaneous have a real solution xy. So p minus 1 equals 1 over 2 to the x, which is 2 to the minus x. So p is equal to 2 to the minus x plus 1. No. What is the complete range of p for which the simultaneous equations have a real solution? Well, that is p. Oh, how do I do this? I've seen questions like this before. I've never liked questions like this. What I have said so far is mathematically true. What is the complete range of value? Okay, let me be guided by the multiple choice. So special values of p seem to be 1 and 2. What happens when p equals 1? Well, when p equals 1, the solution, it's inconsistent. When p equals 1, this thing cannot be equal to both 2 and 1. Let's test what happens when p is less than 1. So for instance, I can choose p equals 0. Then log this thingy would be equal to 2. Because it can't be negative. Sorry, okay, so 2 to the x is 1 over p minus 1. 2 to the x can never be negative. Okay. Which means that this thing on the right can never be negative, which means that p has to be greater than 1, certainly. So it's not A, it's not B. In fact, I want to eliminate these. So it's definitely not A, not B. It's not D. Well, actually, I don't know if I eliminated B yet, but okay, I've considered y1 as special. And it's certainly not all real values. Y is 2 special. What happens when p equals 2? Then I have 2 to the x plus 1 plus log 2 of y is 2, and 2 to the x plus log 2y is 1. If I subtract these again, so 2 to the x plus 1 minus 2 to the x, those cancel, equals 1, which is 2 to the x into 2. So there's 2 to the x's, minus one of them. You just get 2 to the x equals 1, which means x equals 0, which works. Is there a problem with p being... So between 1 and 2, I think is it just this? I think it's just this, you know. If this, because this is a mathematically true statement, 2 to the x, it does equal this thing. And this thing has to be positive. 2 to the x can go to sort of 0 as x tends to minus infinity, which is possible when p tends to infinity. So I think it can be very large. So I don't think it's limited. I think when p is between 1 and 2, you get something. You can get positive and large. Yeah, I think the answer is just C. I'm happy to stick with C. Because again, I'm gonna need this time. I got 40 minutes left. I've got 6 questions left to do, plus I've got to check 7 at the very least. And I know these questions are ramping up now. So exam technique, I'm gonna stay on this, not waste too much time there. This circle, great. Necessary to be a tangent to the y-axis. Well, let's get into it. Right, this is much more fun. So x plus a over 2 squared minus a squared over 4. And y plus b over 2 squared minus b squared over 4 plus c equals 0, which means the circle equation is x plus a over 2 squared and y plus b over 2 squared. You see, this is much more fun when you have stuff that's totally in hand, where you're not thinking too hard, you're just executing without making an error. La-di-da-di-da. So the center of the circle is minus a over 2 minus b over 2. And the radius is the square root of a squared over 4 plus b squared over 4 minus c. So necessary and sufficient for the circle to be a tangent to the y-axis. Tangent to the y-axis means... let's assume for the sake of argument that a and b are both positive. I'm going to know that I've made that assumption, but the point is, if that's there, to be tangent to the y-axis, for how I've drawn it, then it has to be, that distance from the y-axis has to be equal to the radius, and that would be, that distance is a over 2. So that thing must equal a over 2. And I think the answer is C. Oh, no, hang on a minute. But the square root, that's just a distance, though. I think the square root is positive. Necessary. Okay, so it's either E or C. Is it possible? So I think this is going to be a signs issue now. Okay, so let's say the square root was equal to the positive. So a non so okay, this is a sign thing. So let's consider where a is positive and where a is negative. So what I'm going to consider, in fact, I'm going to do it for a and b. What happens when it's positive? What happens when it's negative? Um, well, it doesn't really matter. The radius is positive in all cases because these are squares. And in the case where, and so which quadrants would these be in? So, sorry, this is not the correct way to do the two-way table. So when a is positive, so a positive, negative, b positive, negative. Where a is positive and b is positive, that's there. Where a is negative and c is positive, that's there. Am I evaluating this correctly? I'll come back to this, but I think I really do. It's between C and E, but I do think it's C. I back it, but I just want to make sure I've got good time budget. Because I've done good work on that to at least really limit the cases. I don't want to get bogged down. Okay, so this thing equals that. Has exactly k distinct real solutions for x. Which of the following is the complete list of possible values for k? So how many distinct real solutions can there be for this? How we're going to do this is we're going to plot x modulus of x, and then consider straight lines I can draw through that. So I'm going to first draw mod x, which I'm going to know is that sort of V shape. And then, so here, let's consider the positive branch. That is just y equals x. Multiply that by x, it's going to just become the quadratic. In this case, it would be x would be negative, so it's so that's y equals minus x on that branch. So it's y equals minus x times x. It will be minus the negative quadratic. Y equals minus x squared on that side, and y equals x squared on this side. So let's consider different lines I can draw through this. It is certainly possible to get 0 if I... Is it? Is it, though? I don't know if it is possible to get 0, because that's going to go... When x tends to minus infinity, anyway, I will come back to that in the analysis phase. I'm not quite done with the run yet, so I'll come back to it. I could be wrong. We'll certainly make sure you get the right answer, because I've got the answers and I'm going to go through the solutions, so you will absolutely walk out of this with satisfaction about what the answer should be and why. This is more about like how to put together a run. And with half an hour left, yeah, I'm not too far away from getting you an answer on that. So here, as x tends to minus infinity, y tends to minus infinity. So I think there's no way to miss this branch with any... And similarly up there, I think I don't think it's possible to have a 0. I don't think it's possible to miss. So it's going to be 1, 2, 3, or 4. I can certainly get a 1. Well, then the only question becomes, can I get 4? I don't think I can get 4. I don't see how that would be possible. In a single straight line. Because this kind of looks like a cubic. The only way it would be possible Well, it would certainly only have 2 solutions. You would need to have 2 solutions in each thing. But if I had 2 solutions here on the left, that would have to cross before the origin, which means I'm going into here already with the y-intercept. I don't think it's possible to get it done twice. I'm gonna go with E, but again, I can note that to come back to. 17. Well, that looks ugly. So this is about the ordering, which one's bigger in different ranges. So it's specifically about the ranges. Log, okay, let's simplify. Is log 2 of of x to the half. Now that is log 2 of that half log 2 x equals log 2 a half plus log 2 x, which is minus 1 plus log 2 of x. Similarly for g of x, we are going to have log 2 of log 2x all to the half, which can come out the front of the whole thing. So that's a half log 2x. So f of x is equal to 2g of x minus 1. Okay. Let's consider this. For all x bigger than 1, log 2 of x has to be, well, let's draw a general log graph. A general log graph would go through x equals 1, and so it'd be positive, which is good because then I have log of a positive number, but that positive number could be less than 1, so g of x could go down to minus infinity. So this is or. Okay, so let's get some. Is there a lower limit? Let's consider g first, because I think g will give me f. Well, I mean, as well, let's be informed by multiple choices. Any special values are going to be 0, half, or 1. When x equals 2, log 2 of 2 is 1, which makes this 0. So g of 2 is 0, certainly. So I can get a 0 out. And let me put it in 4 as well. Log 2 of 4 is 2, log 2 of 2 is 1, so I get a half. And just for kicks, I'll put in 16, because log 2 of 16 is 4, log 2 of 4 is 2, so it equals 1. So as I'm going, it is increasing. And you're putting increasing numbers. So I am getting positives when I put in x equals 2. When I put in anything between 1 and 2, though, I am going to get a number less than 1, which means this thing will be negative and going down to minus infinity. So the question then becomes, where's the tipping point? Where's the tipping point where f outpaces g? Okay, so I think it can take, g itself can take any value, but this thing, this f of x in general, so where is this thing? Where is 2g minus 1 bigger than g? Well, that's when 3g is bigger than 1, so when g is bigger than a third. But I obviously did that wrong. I said should have subtracted g, so where g is bigger than 1. So that seems to be the tipping point. When g equals 1, f equals 1, and that seems to be where the g and the f intersect. So I think it's going to be e or f. I think that's going to be the tipping point, is the functions equaling 1. So then the question becomes, well, okay, so when this is when f is bigger than g. F is bigger than g when g is bigger than 1. So when g is bigger than 1, f is bigger than g. And I think that gives me f. I'm never fully satisfied with these ones at the end, but okay, how am I doing on time? Good, I got 3 questions, 27 minutes. I'm pacing this much better. Chooses 2 distinct real numbers with that. Then attempts to draw a triangle ABC. 2 distinct real numbers, x and y. So they're both between 0 and 1, x is lower. Triangle, sine, okay, that's good. Attempts to draw a triangle with sine A equaling x and sine B equaling y. For some choice of x and y, there's exactly one triangle the student can draw. So this is going to be about the ambiguity of the sine rules. So for instance, if sine A equals like a half, then A could be equal to 30 degrees, but it could also be 150 degrees, which allows for 2 triangles depending on what sine B is. And I'm sure that's what this question depends on. So, so for some choice of x and y, where they are different, there's exactly one triangle, which presumably would mean no ambiguity. So for instance, if sine A, let's draw the sine graph. So if I drew them quite close to 1, in fact, let me draw this bigger so you can see. So I know what this is about, so I'm going to just start it again. So y is bigger. So if I draw y there and x there, so if x is very close to 1, then the angle is very close to 90 degrees. Oh, hold on a minute. So let's think about so if y is bigger than x, let's consider this alternative angle for b, because that's y bigger than x. That will always be less of an angle above 90 degrees than this angle A is below 90 degrees. So you've got this. In other words, when you add up x and y, if you add up A and B, this will always be less than 180. So this is always possible because you'll have some budget left to make your third angle. Does it matter why AB equals 1? Let me just... That's A and that's B. So B you can always make 2 angles for. I don't think it matters. I think you just scale it. So I think this is what this is about. So I think I can kind of ignore that. But you can always, so for Y, you can always make 2 angles because you'll always be able to make your third angle with what's left between A and B. So I don't think it's ever actually going to be one triangle, specifically because they can't be equal. This is for no matter where I place X and Y in that, as long as they're different, you will always have some budget left over to make a third angle from the two. So I don't think one is true. I know true is definitely true. And I don't think the only way to have three different triangles would be you could have small a, large b, small b, enough left over for a third angle, small a, large b, enough left over for a third angle. I think any other triangle would require to use the large a value, but I don't think that's possible because this is more above 90 than this is this is more above 90 than this is less than 90. So in terms of budget of angle left over to make a third angle, this has already blown you over 180. So I think the only possibility is 2, and I think the answer is C, if my line of reasoning was correct. How am I on time? Okay, 19. So if it's not right, then it'll be close to right, and we'll find out at the end. Angle theta can take any of those angles. How many of them is it true that this nonsense is true? Right, well, that's not as bad as it looks, because that's sine root of, and so I could take the square root over the whole thing. That just becomes difference of two squares, 1 minus sine squared. Plus, similarly here, this becomes the root of 1 minus cos squared from difference of two squares. But 1 minus sine squared is cos squared, and the root of that is cos. So it's sine cos plus cos sine equals 0, which is 2 sine x cos x, which is sine of 2 theta equals 0. Which is for, it can't equal 0, but it can equal 360. Let me just, so that's 180, that's 360. You can't have 0. 1, 2, 3, 4, D. Let me just, sine of 2 at theta equals 0. For some of these angles, this is sine of 2 theta. For which angles is it equal to 0 in there? It's definitely 4 of them. Okay. F of 1 is the modulus of x. The next function is the modulus of the previous function plus x. Blah. F99. Oh my god. All right, okay, so there's going to be some sort of repeating pattern here. And I'm wondering if the repeating pattern is in this integral. Okay, this is a symmetric integral, so if it is, for instance, if it's an even function, which means it's symmetrical about the x-axis, y-axis. So for instance here, for f of 1, then the integral from -1 to 1 of f of 1 is going to be twice the integral from 0 to 1, and it's going to be non-zero. And while I'm here, I can do even better than that and say that becomes integral from 0 to 1 of just x, which is twice. That becomes a half x squared between 1 and 0. So it becomes 2 to half is 1. But if it's odd, so let's consider what f of 2 is. F of 2 is the modulus, of mod x plus x. Well, that's f1. Let's draw f2. Because this here is y equals minus x. This here is y equals x. If I add x to that, that would just be 0 everywhere here, and then this would become y equals 2x. That's f of 2. And then if I add x to that and take the modulus, so f of 3 would be this sort of situation where this becomes y equals 3x, and this becomes, again, y equals minus x, because if we add y equals x to that, we add another bit of this to that, that would be negative. We have to make it negative to flip that branch positive. So that's f of 3 of x. So I can see the pattern here. So I know what f of 99 is going to be, because the even ones are going to have just 0 when x is negative. But f of 99 is going to look, but this is odd. So f of 99 is going to just be like crazy. So where this on this side is going to be y equals 99x, and on this side is going to be y equals minus x. So that then becomes that integral from -1 to 1 is going to be the integral from -1 to 0 of y equals minus x dx, and the integral from 0 to 1 of 99x dx. So that becomes minus a half x squared with 0 and minus 1. And this becomes 99 over 2x squared with 1 and 0. Plug in 0, you get 0 minus a half. Plug that in, you could just get 1, so it's that, plus 99 over 2 minus 0, so it's plus a half, so it's 99 halves plus another half is 100 halves, which is 50, which is E. I loved that. And I've got 16 minutes left. Okay, so let's go back and check some stuff. Let's go to, first of all, question 7. I want to repeat this because now I think from having done it the first time, I've loosened the jam jar. I know it has to go through the center of the circle in order to divide that in half. I think it can also go anywhere through the center of the square and divide the square in half. So I'm going to just have a redo of 7 with the time I've got left, because I know, well, in fact, no, I'll go, no, I have to redraw it because I just messed up the drawing as well. So I know it goes through 9 minus 2, and the radius is 2, so it touches the y-axis. So it's going to do something like that, and the square was doing something like this. So that point there is 0, 1, and that point there is 9 minus 2, and I think the line connecting those is the one that I want. So the gradient between them, well, it goes down 3 for going across 9, so it's minus a third. And I know the y-intercept is 1, so y equals minus a third x plus 1. Where does that equal 0? When x equals 3, and I think I was correct in saying that's b, using the previous work from before. So I'm satisfied that 7 is b. Good. I also wanted to come back for 13, because I just didn't trust it. To find the simultaneous equations. Let me go find 13. Was this working good? Move that over. Y is less than x plus 3. Y is less than that. It's so tempting to say it's going to be the region in between, but I just don't think it is, because I think it has to be below the quadratic and below the line. So I really do think it's this region in here. So x is not limited in that way. Y does not have to be less than 5, because this goes shooting off to infinity. And as I said before, if these are both supremely negative, then you multiply them together, you get something much bigger than 3. So I'm satisfied with that. I'm just suspicious. This I did not like 15. Um, let me reconsider this. So this is definitely I've got the center, I've got the radius. But you're right, any route. I do not believe I sufficiently considered this. So I've got the time now. Well, I did say I would come back to 6. Let me check the other stuff and come back to it. Because this I felt I know I've graphed it correctly. I do believe in myself that those graphs will outpace any linear graph in going to infinity and minus infinity. So it's impossible to draw a line that outruns it. So I really don't think it can be 0. And I don't think it can be 4 for the reasons I described before. I just don't see it. I don't see how if you create a line that intersects both of them on this side, that you've introduced an asymmetry. So it by symmetry, it's doing to the other side what would happen if I had the exact same line intersecting with a negative intercept there. It can only happen once. It just can only happen once. So I think you can only get 3. I'm satisfied the answer is E there. I think I'm satisfied with what I did here, relating f and g and finding out where they swap places, which is around the g equals 1 mark. And that f is when g is bigger than 1, f. Well, where is f bigger than g? When g is bigger than 1. So when g is bigger than 1, f is bigger still. I do believe that's f. And then below that, they swap around. So I did like that. I did like this. I like that a lot. I liked that a lot. Now, it's always the case that you could just be missing something. So it's not that the work I did was bad, but I could have been neglecting something. And speaking of neglecting something, let's really sort out 15 now. I've got 10 minutes on the clock. Okay. The problem with a condition that only has B in it, I suppose. We do need the distance from the y-axis to be equal to the radius, and the distance from the y-axis is a over 2. So that distance is a over 2. Let me zoom in a bit. And that distance, I think I'm seeing this too high level. I need to get into the detail here. How do I find my way to this? But the thing is that, yeah, the signs, the fact that it could be either or, it does make me think I could be missing something. Well, we definitely require the radius to be positive, and I'm wondering. Circle to be tangent to the x-axis. Oh, I'm going to do this a completely different way. I'm going to do this a completely different way. Tangents, I'm going to use points of intersection. Okay, I wonder if this will work. So what is true? So we're going to find the point of intersection between x squared plus ax plus y squared plus by plus c equals 0. We're going to find the point of intersection between that and the line, which is the y-axis, which is x equals 0. In order to do that, I know I substitute the line in, and I get a quadratic. So I substitute x equals 0. That means this is true. And I know that so that gives all the places where the lines intersect. And I know if it's a tangent, I want there to be one intersection point, which means I want the discriminant to be equal to 0. So b squared minus 4c equals 0. So b squared equals 4c. I think it works that way. Okay, so you're here now. We can equate a squared over 4. So let me find c. Maybe. I'm satisfied with how I did this, so I think the answer is B, and I think you're right. 6 minutes on the clock. Do I want to, for the purposes of exam technique, I'm going to spend the last few minutes trying to spot any execution errors, but then the second I'm done, I'm going to come back to your point anyway. But I want to try and score as highly as possible, which means catching any potential mistakes, especially in the earlier stuff when I rushed. 6.5 minutes, not a lot of time, but let's see what I can do. First of all, the first thing you do when you think you're done with a paper is to make sure you've actually answered every question. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Everything is at least answered. Okay. Good. Now let me see if I can check. I checked all the ones that I felt were kind of dodgy. This, no execution errors. 3 over 2, it's 2/3 of that. 3 over 2, divide by that, so it's times 2/3. 3's canceled, that's definitely 2. 3 over 2, raised to -1, divide by that, cool. 2, 3, 8, 16, minus 4 over 4, 1, yeah. 2 minus 4 minus 2, 15 minus 2, 17. Good. I'm satisfied. Opposite vertices, it goes down 2 for going across 4, minus a half. Perpendicular bisector, flip it to 2, goes to the middle, which is 2, 1. I like it. Y minus 1 equals 2x. It says it's 2x minus 3. I like that. I liked this a lot. I liked this a lot. I liked this because the cause could be the negative square root. I liked this. I think that was well considered. I liked this the second time round. I liked when I combined the two. I'm pretty sure the answer is B. I liked this, what I did there. I liked this. I liked how I considered all the cases. Yep. I liked that. This I was like not 100%, but I'm pretty sure I got that right because he proved the converse. He proved that if this is true, then this is true. What am I doing time? Got about 4 minutes. It's probably not the best way to check your work, but I'm putting it out there anyway. We can talk about that in my analysis. Because I don't think this would have been good in reverse order, that step dividing by algebra. Okay. I liked this by considering all the cases. I don't trust this. Oh, 14. Was I happy with 14? That is a mathematically true statement. That is a mathematically true statement. Oh my god, that's 2 to the minus x. No, wait, hold on. That's from here. No, flip it around. No, that is a mathematically true statement. That has to always be positive, so p has to always be bigger than 1. Is that range definitely complete? 2 minutes on the clock. It can be just, if it's just bigger than 1, then this shoots off to infinity, which we know 2 to the x can do. If it goes off to infinity, then 2 to the x goes to 0, which is, I think this is considered. I think, yeah, p bigger than 1, I like. I liked this the second time round, but it goes to show, I mean, we'll talk about that when I'm done, but I'm pretty sure it is that, the second time consideration. I liked that, and I checked all the others. I've got 2 minutes on the clock. I think the rest of this I feel good about. It doesn't mean it's right, but it feels like means I feel good about the work that I did. And I don't think I'm going to spot any mistakes very quickly in a minute and a half. So why don't I call time there? And we'll go through. Okay. Anyway, I hope that did give clarity. First thing I want to say is I'm happy with how I skipped. I'm happy that I did some good work to sort of loosen the jam jar, but then like if I noticed I got it wrong, so 7 was a prime example. I'm really happy with how I like did it the first time, knew I got something wrong, but knew I'd still uncovered some truths that I could use for the second time round, and didn't waste time on it in the moment redoing it then and there, because I knew it was going to be done sort of quickly the second time round. And I'd had enough of a sort of inclination about what was going to happen that I could put in a good educated guess just in case I didn't have time to come back to it. So I felt good about that technique. And similarly, I felt good about when I did that on 15. So what I liked about how I did 15 was I tried it one way. It wasn't, I could sense that something wasn't quite right because like I couldn't see that the plus minus was different. So it just felt off. And then I managed to come up with like that solution path just wasn't working for me. And I'm pleased that I came up with a totally alternative solution path. And I'm a bit annoyed I didn't think of that first because I actually really like points of intersection between lines and circles. But okay, so those are the two things I think I did well in terms of technique. I also like that I gave myself enough time to properly check everything. That's something I haven't done in one of these runs yet. I think let's mark it up and see how I did. Let's beat 15, guys. Let's set a PB. So we've got the solutions here. I should really just have the answer key. Oh, well. No, let me get the answer key. Because I think it'll be hold on, TMUA. Apologies for this. Answer key 2021. Because the solutions are good for if I do something like horrifically wrong. But I think the answer key is good for just really rapidly going through, just in case. Okay, so paper 2 of 2021. D, yes. E, yes. C, yes. C, yes. B, yep. D, yep. 7B, yep. 8, no. 8 was C. So doc 1 on 8. Let's see what I didn't consider. I'll come back to that. 9 also did not do it. Okay. So this will inform what I need to revise then. 10E, 11C, 12B, 13A. So it was correct. Okay. 14C, 15B, which I did get. 15B I got the second time round. Let me just check that. 15 was B. Good. 16 E. 17 F. 18 C. Yes. 19 was D. All right. It was F even. Okay. So I missed something there. And 20 was E. Good. Okay. So 17 out of 20. We're still ticking up. Let's mark it up and let's see what changes I can make to my process for next time. Okay. So let's get these answers correct. So 8 I got wrong. Let's get into Y. So 8, the option was C. Let's look at the question. So what did I say? I said that for a C between A and B, which is a turning point. Oh, I did it the wrong way round, I think. Oh, no. I said I did it for when the start statement was necessary or sufficient for the condition on the left. So that was that fault in logic. I should have considered the other way around. Does this statement cause a turning point in between? Well, that doesn't cause a turning point in between, like I said there. I said it was neither necessary nor sufficient. Is it sufficient? Oh, of course. That's not a valid counterexample because that's not polynomial. The definition of a polynomial is it has to have integer, like positive integer powers of x. So actually for a polynomial, them being equal would be sufficient, but not necessary. That's why I got that wrong. Let's see what they have to say about it. All right. It doesn't explain why I made that mistake, but that's why I made that mistake. Okay. So they were being very strict about the definition of polynomial. Okay. So 9, the answer was C, and I said D. So I got wrong the sufficiency of statement 2. And it's exactly the same issue. That is so frustrating. So yeah, I just didn't look closely enough at the definition of polynomial, which cannot be 1 over x. It has to just be whole powers of x. So it is true that so the logic was mostly there. So here they do have to have opposite signs, but in a polynomial, the only way that's possible is to have a real solution in between because the sign flips. So that's so frustrating. If I'd looked more closely at the definition of polynomial, I'd be up to 18 out of 19 by now. And the other one I wrote down F, which was unhelpful. Which was the other one I got wrong? Let me check. So 10, E, C, B, A, C, B I got right the second time around. E, F, C. It was 19. So yeah, I did it for general functions, not just for polynomials. That hurts. Okay, why did I get this wrong? Root of 1 minus sine squared, that is cos squared. What did they say the answer was? It was actually F. Oh. Okay, there's something I'm missing here. Oh, it's going to be a positive and negative business, isn't it? Oh, that's frustrating. Okay. So I did oversimplify this. So what I'm thinking now is I didn't consider the signs because of it equaling 0, this assumes in regions. Yeah. So if it's ever the case, although, okay, I'm going to draw my cast diagram. Okay, I understand. The square root will always give the positive. That's what I missed there. I thought that was too easy for a 19. So the square root will always give a positive. So in other words, it's kind of like sine theta modulus cos theta plus cos theta modulus sine theta. That's what I missed. And then if you consider the cast diagram, which is my preferred method of, making sense of this, in the A region, it is certainly, 90. Do these four still work? Yes, these four still work. Because in each of these cases, one of either sine or cos is going to be 0. But in the other regions, in the S region, where sine is positive and cos is negative, that's the modulus of cos, which turns it positive again. So that term becomes positive sine theta cos theta for the actual values, but that cos negative, they will cancel out everywhere in this region. And similarly, it will cancel out everywhere in this region where sine is negative, and that flips back around to cancel out. So it will be every angle from 90 to 180, and it will be every angle from 270 to 360. So that's 91 angles inclusive, and 91 angles inclusive gives the 182. That is so sneaky, and I'm not even upset about losing to that. That's fair. They can have that one. Let me check I was right on that interpretation. So 19. Yeah. I'm right. Did not spot. Okay, so how could I have done better on that? The problem I did was assuming that the square root of cos squared was just cos x, and I didn't consider. So I should be more alert in future whenever I see a square root. Good to know. So 17 out of 20 could have been 19 out of 20 if I'd just been more diligent about the precise definition of polynomial, read the question forensically. Is there anything I feel I need to explain in more detail? No, I think that was good. I do think that was good. I think that was good. Yeah, let's go into. No, I think that's fine because I paid attention to the square root issue here. Here, it made sense to me that it was going to be, the positive versus negative of it all when you take a square root. I think that was fine. That's just where the issue was. Explained that in detail. Explained that in detail. Actually, I can see what I explained in detail. Let me look at my work. Let me make sure you guys get valid explanations. Okay. So 4 and 5, I just sort of did. But I think I explained them okay out loud. So it's only a valid counterexample if the claim actually applies to it. The claim does, so A is a factor of BC in all of these cases. And 3 is not a valid counterexample because of the or. So it's because it is the case that A is a factor of C, then this second statement is, taken as given. And also, it doesn't matter in part one that it's both, that the or is still satisfied, so it can't be one. So that's why it was only two. This one, yeah, I'm satisfied. 8, 8, 9. I just polynomials, Patrick. You come on now. That I think I did fine. Okay, this actually every line of working does follow. Once I'd caught my mistake about going from line 2 to line 3. So then it was a case of reverse order versus converse. And so the only thing that seemed like they should have been very similar. So the issue was going from 4 to 3, dividing by the x squared, y squared. Yeah. Ooh, I'm not offline. So I was satisfied with that it was the converse. Now, what is the converse? So the converse is the same statement with the if-then clauses flipped around. So instead of saying if this, then that, you say if there is a real number such that A is all this stuff, then this inequality holds. Which is, so in a logical proof, you should start with your if and arrive at your then, but they started at the then and arrived at the if. So they started from a mathematically true statement, worked it validly through to this point, and then started the, well, if this is true, then that is a squared, and that is 4b squared, 4b cubed, and therefore that is true. So they started from the then, worked to the if, so they proved the converse. 12, I think I explained okay. 13, I explained okay. 14, I want to see if they liked my method for that. I didn't consider why. So I think I kind of got lucky there that I only considered the 2 to the x, and I didn't consider what was happening on the log y. So that's something I can do in future. So just remember, simultaneously, if I'm working out these sorts of bounds and regions, I should consider the effect on everything because it asked for the complete region. And I don't think I did that completely. So that's good to know. But yeah, the argument was the same. So they got to the 1 over p minus 1, which had to be positive. So p had to be bigger than 1. 15, I got there in the end. I really liked my second path about the point line and intersecting a circle. Let's check if they had so there's multiple approaches here. Sketching. Yes, the modulus of minus a half a. So they squared both sides. Okay, so I was that close. The square root, which was the radius, equals the modulus of that. Square both sides. Cancel that down. You get there. And then I found the second way, the second time around. So it wasn't too far off the first time, and that's good to know. But it was just that it wasn't that, it was the equals to the modulus of that, and I should have followed it through. 16, yes, I like. So if it intersects twice on that side, it has to intersect once on that side. Yep. So I was satisfied with how I explained that. I was definitely satisfied with that. I'm curious to see what they did here. Yeah, exactly the same thing. Good. 18. I felt like I explained that well. And I do, whatever this is, I don't want it. Don't want it. Do not want it. But it's I like the way I did this, thinking about two angles, how to combine them such that there's enough angle budget left over to make up a third angle. So what I could have done to explain that in a bit more detail maybe is, no, I'm satisfied. Well, at least it made sense in my head. If anyone has any, I can. If you want to drop a comment down, I'll be happy to give further clarification on that. This I explained. I just didn't consider the effect of the square root of cos squared, that it was going to give you the modulus of cos and sine. So I just overcorrected on that, made that too simple. And this I absolutely loved. So if you just plug in the first few, you get a sense of a repeating pattern. And that worked out. So in conclusion, as expected, well, first of all, I'd picked up on all the exam technique corrections I wanted to make for my prior runs. So I feel good about the technique now. I'm skipping in all the right places. I'm making sure I'm using my time budget well. What I need to do conceptually in order to improve my execution. So exam technique was fine. Those were all execution errors. And the reason why I made them was because I didn't sufficiently consider the detail in the question. So I need to more forensically read the question in future to think about potential traps. As I said right at the start, I felt good about the work that I did, but it was likely to be things I was overlooking. And that was exactly the case. I was overlooking the consequences of square roots, and I was overlooking the importance of the definition of a polynomial, and instead just considering general functions. So in future, if I read questions more forensically and preempt possible traps, that will guide my thought process and make it more likely that I get the correct solutions. I don't have time to get a paper one in, and besides, that would make the stream too long. I'm satisfied with that, so I'm going to leave it there. Let me know if you guys have any questions. Next week I'll cover. I'm going to keep doing this. I'm going to keep alternating NSA, ESAT, and TMUA until we get through the sort of January cycle. And I'm hoping, so I'm trying to do much more process work, showing you what it's like to sort of lock in, get a good run together, and also making sure you get the content. But hopefully just watching me go through the process is helpful for guiding your process. And look what you're seeing with me in the TMUA, right? 14, 15, 17. I'm going through the long practicing process that works and is actually getting me improvements. So hopefully by watching me go through that, you can sort of take things on board yourself, get yourself to where you need to be with paper 2. I should also make sure I do the paper 1 in case there's anything sneaky happening in there. But all right, I'm going to leave that there. Continue working hard, guys. Have fun. And I'll see you at the next one. All right, bye-bye.